So let's talk about functions. We're going to talk about functions. We're going to talk about the vertical line test. And we're going to talk about even and odd functions as well as graph transformations. So let's get started. Vertical line test. That's just one of the ways to know if a graph or a function is, or if something is a function. So if I draw a vertical line through this function and it crosses more than once, that means that it is not a function. Now over here, if I draw a vertical line, notice each time I do these, it is right. It's only crossing the graph once, so therefore it is a function. So the vertical line test tells you whether you're a function or not. And then there's another test actually, as a quick side note, called the horizontal line test. That tells you if you're a one-to-one function. So let's think of a classic one-to-one function. That would be like y is equal to like a linear graph, right? Like a linear graph, a graph of a line. I mean, linear function. So that means that it passes the vertical line test and it passes the horizontal line test. That means for every value of x, there is only one corresponding value for y. Now, with a parabola, where you have a parabola like this, we can have, for example, we might be at -2 and we get 4. And over here, we have 2 and we get 4 as well. So there's a y value that corresponds to two different x values, and that's so for -2 we're getting 4, right, when we square it, and when it's 2 squared we get 4 as well. It is a function, but it is not a one-to-one function, and that's okay. No problem if you're not one-to-one, if you're not a one-to-one function. I just wanted to let you guys know there is a difference between the vertical line test and the horizontal line test. So we've talked about the vertical line test. One of the things that I want you to be familiar with is there are a group of there's a chart in a typical pre-calc textbook, for example, where it talks about parent functions. Now, for parent functions, it's important that you recognize what the original functions are before we sort of transform them or move them around. So, for example, the linear function, right? That's the one where you just have a line like the y is equal to mx plus b, right? It's good to know the type of function, and it's also good to have an idea of the domain and how that works. For linear functions, it's all real numbers, right? All values are valid with linear functions. Let's look at a few different types of functions. Then there's the parabola, right? Or let's call it the quadratic function. The quadratic function, I mean. So if you have the quadratic function, which is a parabola, right? You have something like that. That's the parent function, right? And this is just a sketch. So that's y is equal to x squared. Now we can change, if we want to transform it and say y is equal to x squared plus 2, that means we move up 2 units. Do you see where the transformations begin? If it's y is equal to x minus 2 squared, we move to the right 2 units for that graph. And so there's different ways to transform the graph, but generally you have vertical and horizontal shifts that are important to our discussion. So we have the linear function, we have the quadratic function, we have the absolute value function, absolute value. For the absolute value function, that's where you have, it looks like a V, right? So that's like a V. So think of it like a V. That's an absolute value function. You can move it up, to the right, to the left, down, and so on. Then we have a square root function, right? The square root function kind of looks like that. That's a square root function. So the square root function, the important thing to keep in mind with the domain is that with these, especially when we're dealing with in the real plane, you want, if I ask you to graph x minus 2 like that, right? That's going to be a graph transformation that is going to shift that line, okay? But the importance is to keep in mind, if it's square root of x minus 2, that means that the domain has to be, x has to be equal to or greater than 2, because if I put anything less than 2 here, it will make this a negative square root. So the domain would have to be, in this case, 2 to infinity. So that would be the domain. 2 is okay, but nothing less than 2. So so we have the linear, we have the quadratic, we have the absolute value, we have the square root function. The cubic function is an interesting one to keep in mind, because we're going to talk about even and odd functions in a second, and that's the cubic function. Y is equal to x cubed. And again, you can move that around, but that's the graph for y is equal to x cubed. The other ones I'll just mention briefly. We have rational functions, and actually I'll just sketch them too. We have rational functions. So rational function, you have asymptotes involved. That's y is equal to 1 over x. That's your rational function. And you have something like this. That's the rational. Sorry, it's curved, right? You could sketch this on Desmos calculator or something else. So we have the rational functions. We have exponential functions. That's where you have y is equal to a to the power x, for example, where you might have a graph that looks like a graph that goes like that, right? And this is important also in the science portion of the ACT, understanding the nature of the graph of something. Then there's the log function, right? Again, you can sketch using a table of values for these, but I'm just showing you something to keep in mind. That's the log function. So we have the log function, which is, of course, you have log base a of x. So if we have f of x is equal to log base a of x, that's a log function. Exponential function is shown below, rational function. And those are the main ones that you should know. The last three I'll mention here, sine, cosine, and tangent. Again, this is just a sketch, and we have a sketch of sine, and we have a sketch of cosine, right? So remember that it goes from 0 to 2 pi, and here we start at 1. The amplitude is 1 for this default one. It goes up and down before it repeats the cycle, right? The period, sorry, we call it the period. And then the last one, the tangent function, is the one that you would see with like asymptotes. And so when you have that with the asymptotes, like that, like that, like that, these are sketches. You can sketch that, f of x is equal to tan x, and you can see what that looks like. So we've talked about rational, exponential, log function, sine, cosine, and tangent, and then linear, quadratic, cubic, square root. We talked about those earlier. These graphs can be transformed, but it's good to at least have the basics down. So these are some details with functions. So let's end by talking about even and odd functions. Let me give you an example of an even function, okay? And an example of an odd function. If f of x is equal to f of negative x, and this one, if f of negative x is equal to negative f of x. Okay, so let's talk about these two situations. Even. So you think of x squared. If you plug in f of x, it's x squared. What if I said, what is f of negative x? It's also going to equal x squared. So notice that f of x was equal to f of negative x. So when we look at an even function, so first I've shown you one way we can derive it. The other way is look at the symmetry. It's right going through this line. That's where there's symmetry in the function. So we call it an even function. You see the symmetry occurs. Let me use a different color. Right here. So there's a symmetry right there, okay? Now imagine if you have a graph. Let me just use the graphical for the odd and we'll come back, like the cubic function, okay? And in this graph, we have y is equal to x cubed. So now I'm going to draw the line that actually will help you see where the symmetry is. And it's actually the line y is equal to x. So if we were to draw the so we've drawn this line through like that, okay? And the symmetry occurs at y is equal to x. This is odd, okay? This is an odd function. Notice the behavior here, the behavior there, and then notice this part of the graph and this part of the graph. So notice there's a symmetry, but it's through y is equal to x. Now let's show it algebraically. F of negative x would be equal to, we put negative x in for x, okay, x cubed, we get negative x cubed. And then what is negative f of x? That would be minus into x cubed, which would be negative x cubed. So we can see that it is an odd function. Now, not all functions will fit in the even or odd situation like the one I just wrote. So keep that in mind. Sometimes it's neither, but if you want to know if it's even or odd, you can find it algebraically, and that's what we did. We can do it algebraically, we can do it graphically, and we can find if functions are even or odd. And I know I did going to stop after even and odd, but I just wanted to leave you with graph transformations now because I did talk about it before, but let's just remember that you can take a graph like a parabola You can move it from its default. You can move it up. You can move it to the right, right? When you move it up, it's usually, again, the default is this. That's the default of the function. But let's say I gave you a question like x squared. If you move it up 3 units, then it's y is equal to x squared plus 3. If you move it to the right 5 units, it's y is equal to x minus 5 squared. You can move it to the right. You can move it to the left. Vertical shift, horizontal shift. You can reflect it, right? And that would be, if I was to reflect it, then that would be like y is equal to negative x squared. That's a reflection of that one. Something to keep in perspective. You can shrink, you can expand it. Those are things to keep in mind. This form here is very important to keep in mind. There's problems we can look at for how to derive this for different functions. Let me know if you have questions on that one. Just send an email saying, let's call it the vertex form for parabolas, right? In the vertex form, we can derive that and use that information to sketch our graph. If they give you a standard quadratic, you can basically try and convert that into the vertex form, and then you can solve. You can sketch it on the graph using graph transformation. So again, we can move up, we can move down, we can move left, right, and so on. Remember that with functions, you can add the functions, you can subtract the functions, multiply the functions, divide the functions, and what that involves is where you have like if f of x was 2x and g of x is 5x squared. You just add the two together. We're adding the functions together. Composition of functions is important. We'll probably keep that for another video. But at this point, just make sure that you know how to add and subtract functions, and then your composition of functions as well.